In this video, we're going to talk about transverse and longitudinal wave. So, transverse wave, they are vibration. It is the vibration of the particles in the wave that are perpendicular to the direction of the propagation that give transverse wave. So previously in the flight simulation, we already looked at some example like the rope that is swing, okay, and then the wave travel away from the point of disturbance, and also the water waves example that I show to demonstrate the progressive wave. Okay, so remember this keyword here, vibration of the particles. Okay, those particles that are at their position vibrating, right? So they are always perpendicular to the direction of propagation. That means the direction of travel of the wave. Okay, so like this kind. So see the wave profile moving like this, but those particles here, they are just moving up and down perpendicular to this direction of travel. Okay, sorry, I'm gonna go to the next slide. Okay. Okay, whereas longitudinal wave is the vibration of the particles that is along the direction of the propagation of the wave, so parallel or along the direction. So example like this. Okay, that's the sound wave that I also demonstrate using the flight simulation. So you can see that the wave traveling like this, transferring the energy from the left to the right, but those particles here, actually they are just moving left and right if you focus on them. Okay, next one, the trough and the crest. We already mentioned that earlier. And for longitudinal wave, we use the term compression and rarefaction. Okay, we use the term compression, rarefaction. Compression is where they get very close together, and rarefaction is where they separate away from each other. So longitudinal wave, now we focus on that. That we have the spring here originally is undisturbed. This is the undisturbed one, and then after that, when it's disturbed, this is like a snapshot of it at a certain moment, okay, through time. And then the one below here is the graph. So the graph here, you look at it, it is up and down, but the labeling here is actually to the left and the right, because you can't draw the left and right motion, right? I mean, show on the graph. So it should be a displacement up and down, but indicated to be left and right. Okay, so now I'm going to elaborate on one of the things here, which is how to identify that it is a center of rarefaction. If you don't know that if you are not given the picture in this box here, you actually will not know easily where is the center of compression and where is the center of rarefaction. So let's say you just have the graph at the bottom here. So how are you going to identify? So idea is very simple. You just have to use your two thumb. Okay, so we see that the one on the top here pointing up, right, is to the left. Okay, so this arrow is pointing to the left. That means that all this displacement, right, all this displacement on top here, they're actually to the left. So to the left means it's like that. Okay, to my left, and then to the right is down. The one at the bottom there is to the left. That's right, to the right. Okay, so now we focus at one point here. Let me use a different color and clear off first. So okay, so let's focus at this point on identifying where is whether this is a center of rarefaction or compression. So first of all, let's look at those particles around it here. So this particle is moving to the left. Okay, so imagine that there's the point there in the middle here. So to those on this side that I circle here, they're actually moving to the left. Okay, so the point is in the middle here, and then those here, they are moving to the right. Okay, so I'm going to place my finger like that. So this is where the center is. So this is definitely a center of rarefaction, because those particles, they are moving away. Okay, so if you still don't get the idea, we'll move on to see the example of compression. Yeah, so this is a center of rarefaction, and let's move on to this one now. Okay, and then first of all, our left hand, these particles here, they are actually moving to the right. This particle on the right here, they are moving to the left. So that's why you point like that. Okay, so point like that means that those particles are moving like this, because this going to the left, this going to the right, so they are going to compress each other. That's why that point there, it must be a center of compression. Okay, so I give you one more example. So you identify that. Identify the center of rarefaction and compression. Okay, rarefaction and compression. So you use the same idea just now, and to see whether you can find out or not, you can pause the video before I show you the answer. Okay, you do for this and this, this one and this one. Okay, you pause the video. Now I'm going to show the answer. Okay, so for this point here, let's say point A, those particles on the left here, they are pointing to the right. Okay, this particle on the right here, they are actually going to the left. So this one is actually a center of compression. So let's label it C. So point B here, those particles here, they are moving to the left. So moving to the left like this. Then these particles here, they are moving to the right, according to the label here. Yeah. So like this. Okay, so they move away. That means that this one must be the rarefaction. Okay, center of rarefaction. Now we look at some example of transverse wave and also longitudinal wave. Transverse wave example is like the electromagnetic radiation, light wave, radio wave, microwave, X-ray, gamma, and all that. And secondary seismic wave, or we call the S wave, is also a type of transverse wave. So, but it's not so important, just to let you know as a second example. Or you have a rope that you try to make an oscillation on the rope, and also water wave, as in the droplet drop in and it travel away. So that kind of vibration is also that kind of wave is also transverse wave. Yeah. And then the next one is the longitudinal wave. So this one is like the sound wave, okay, that I demonstrated in the FAT simulation. And then the other one is the primary seismic wave. Seismic means the earthquake lah. Okay, or we call the P wave. So means that earthquake actually has two types, depends on where is the epicenter or center of the center point of where the earthquake is originated from. Alright, so I'll see you in the next video.